PCH, the day has finally come when we get to start the first unit of AP Calc together. I could not be more excited. I hope you are pumped up too. I'll be honest with you, the most fun I had doing math in high school was when I was in AP Calculus, just as you are about to be next year. And this stuff is, I don't know, unlike anything you've ever seen before. So get ready. We're going to have a really, really good time. And so, in order to get started, I want to take a look at our scope and sequence for the course as a whole. Obviously, this year, or like at the end of PCH, we're just going to be focused on Unit 1, which is over limits and continuity. And if we're focused on the exam weighting for just AP Calc AB, which is what you will be in next year, you'll notice that between 10 and 12% of the entire AP exam is coming just from this first unit that we are covering together. This unit is important. It matters. Imagine going into AP Calc next year on the first day of school and you could already do 10% of the AP exam. Like, that's pretty legit. And so I want to use that as framing for us as we go through this unit. It matters. It's important. And so we're going to spend the time that we need to make sure that we understand it really thoroughly. As we look at what is included in this unit, AP provides a course at a glance. And as we look at this first unit, which is again over limits and continuity, we see that it's pretty long. It's about 16 lessons. We will cut some of those out. We will combine some, but for the most part, we will be following this course at a glance to a T. And so you might notice if you're looking at our notes for today, we are going to be talking about estimating limit values from graphs, and that is lesson 1.3 in the course at a glance. All right. One thing that is super, super cool about what we will be doing, and you'll have access to this next year as well, is that because AP is super aligned with Khan Academy through College Board, there is an entire AP Calc AB page on Khan Academy. And as you look through it, you will see that there are a bunch of different units. And what do you notice about the first unit on Khan Academy? It is limits and continuity. Oh my goodness, it completely aligns with the course at a glance that AP provides us. There is a reason why we are going to follow that, and it's because Khan Academy follows this order as well. And you'll see that one of the first practices in this unit in Khan Academy is estimating limit values from graphs. And so something I want to reiterate that is something that we haven't necessarily had before as accessible as this is that let's say we're going through a lesson together and it's just not clicking with you. Something about it's not making sense. You're struggling to understand what we're working with together. You can always go to Khan Academy, click on whatever lesson you're doing, and they will have videos, they will have articles, they will have different practices that you can do. All of this is available to you to supplement what you're doing with me. And so some of these practices I will assign because I want you to do them for sure, which is fantastic. We're actually going to have some of those today. But otherwise, this is something you can access at all times, which is really, really cool and something we haven't necessarily had before. Awesome. Well, let's go ahead and get started with our do now then. You have it in front of you. Some try-one spiral. Find the horizontal asymptote of each of these three equations. When we are talking about finding the horizontal asymptote, of course, we are focused on the degree of the numerator, comparing it to the degree of the denominator, and we're seeing if it's bigger on top, bigger on bottom, or do we have the golden ratio? And so when we're looking at letter A, for example, and you'll see a graph of this to the right, I graphed it on decimals for us, we have the golden ratio, which means we're looking at the coefficients in front of our leading terms. And that's what's going to give us a horizontal asymptote at y equals 3. And we see that on the graph here. We see the horizontal asymptote at 3. We see a vertical asymptote at x equals -2 coming from that factor in my denominator, of course. And something that we know is that horizontal asymptotes determine end behavior. This is going to be our first connection to calculus, our first connection to limits. And so when we're connecting to what we know, and we're talking about a limit, all a limit represents is a y value. A y value. Saying, hey, as we're looking at our graph, and as my x values get larger and larger and larger, they get closer and closer to positive infinity. Well, what y value is my graph approaching? And we know that this graph is going to get really, 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 really close to my horizontal asymptote at y equals positive 3, but it's never going to touch. And so if I'm thinking about the limit as x approaches infinity, as my x values get really, really big, like we were talking about, of f of x, what y value is my graph approaching? Well, it's approaching 3. Folks, you have just done your first limit of AP Calculus. And something I want to touch on that's very, very important is what I have here for expressing a limit verbally. All of this stuff that we are talking about is completely new to us. We have not talked about limits before. We've never talked about trying to express them either in writing or verbally. It's going to be very important for us that we are going to be able to communicate about limits and be very specific about what limits we're communicating about. And so as you were writing this down and as we were doing different practice, I want to challenge you and push you to continue to try and practice verbalizing how you say a limit out loud. Let's go through it one time together. So if I'm looking at what I have here above, the limit, say LIM for limit, as x approaches, so this arrow means approaches, the limit as x approaches infinity, and that can be any number. In this case specifically, we're talking about a limit where x approaches infinity, but we could easily have the limit as x approaches -3, the limit as x approaches -25. It can be any number, and we'll call that c, of my function of f of x equals some value. Excellent. I want us to get some practice for examples that aren't necessarily approaching positive infinity. And so you will have a Desmos that I will give you the link for in just a second. And you will see a graph that is some stuff is happening. You will have some questions that you're going to answer. I just want you to focus on completing the first 5 slides before we come back to the Ed puzzle and continue our notes. Let's do that now. All right, what you just discovered in the Desmos was the difference between one-sided limits and two-sided limits, as well as how function values differ from limits. And so let's go ahead and actually head to our notes and talk about the difference between one-sided limits and left-sided limits and sum those up. And so the reason we're even starting with limits is because they are the connection between the things that we know already, our algebra, our geometry, and just the way that math works, and the calculus. And so that's why it's really, really important that, this seems really simple, but it's going to come into play throughout a lot of calculus. And that's why it's on so much of the AP exam. And so when we're thinking about the right-handed limit, that is, hey, what is happening? What y value am I approaching as I'm approaching some x value from the right? And we can think about it in terms of hey, my negatives are over here on the left, my positives are over on the right. And so I'm thinking about a right-hand limit. That notation is going to look like the limit as x approaches. Now, of course, this is going to be any number. I'm going to represent it with the letter c, just because that stands for a constant. C is a number. It is a constant. So the limit as x approaches c from the right, so from the positives of f of x, that is going to be my right-handed limit, which is a one-sided limit. Same thing for left-handed limit. It is also a one-sided limit. I just care about what y value my graph is approaching as I approach an x value from the left. That is going to look similar, except instead of a superscript plus, it is going to have a superscript negative. So the limit as x approaches c from the left of f of x. Excellent. That allows us to end with the general limit, which is the two-sided limit. And that's what we've already been practicing a little bit before. The limit as x approaches c of f of x. We don't have any superscript, no plus, no minus. We care about what's happening from both sides. The limit as x approaches c of f of x. Now, of course, I talked about how important it is for us because we are excellent mathematicians who want to be able to communicate about math verbally, not just writing it down and doing problems. And so it's really, really important that we, again, practice saying this notation with words. And so you'll see in the right-hand column, I have written out each limit and how you would say it verbally, highlighting the fact that the main difference between the first two is that that superscript plus is going to be read as from the right. So the limit as x approaches c, which is the number, from the right of f of x. My left-hand limit is going to be the limit as x approaches c from the left of f of x. And then you can go ahead and read our two-sided limit. What I'd like for us to do now is pause for a second, and I just want us to read these three things out loud multiple times. Just get it out in the open so that we can hear ourselves say it. Let's talk about the limit existence theorem. Now, when we are talking about finding limits, I'm going to emphasize again that all that means is that we are looking for a y value. A limit is a y value. But when we're talking about the limit existence theorem, we are talking about the existence of a general two-sided limit, which was that last limit in the third row of the notes we just took. And we can say that the limit as x approaches c of f of x, again, no plus, no negative, this is the two-sided limit, so we care about both sides. It exists if and only if the one-sided limits exist and are equal to each other's. So the limit as x approaches c of f of x exists if and only if the limit as x approaches c from the right of f of x is equal to the limit as x approaches c from the left of f of x. And so let's talk about that. If we are going back to the Desmos, on one of the slides, you had the option to kind of look at things from both directions. Let's click on this first one. This is showing us the limit as x approaches 1 from the left. We do not care about what's happening on the right side of x equals 1, just on the left. And it looks like it's approaching a y value of positive 2. Sweet. Let's talk about the limit as x approaches 1 from the right. Again, we don't care what's going on from the left now. We just are focused on what's happening from the right. And it looks like as x approaches 1, we are approaching a y value of 3. Because my two one-sided limits are not the same, that means that the general two-sided limit, the limit as x approaches 1, does not exist. It can't. They have to be the same. The one-sided limits have to be the same. That is the biggest thing about today, is the limit existence theorem. All right, let's go ahead and try some practice. Again, if we are looking at letter A, the limit as x approaches negative 3 from the left, so I'm looking at x equals negative 3, which is here, and all I care about is what's happening as it approaches from the left because of this negative superscript. Something I noticed is that my y values are going up increasingly, like forever and ever and ever. They're going to never stop going up because they're going to keep approaching my vertical asymptote at x equals negative 3. And so when we're talking about this limit, we can say the y values are approaching positive infinity because they're going up forever, but we also want to say, hey, this is unbounded. Because as we know, infinity is not actually a number, we need to also say, and this is what you'll see on Khan Academy as well, is that this limit is unbounded. It is going on forever. Let's try another one. The limit as x approaches -5. There's no plus or minus superscripts. That means I care about what's happening on both sides. Let me get rid of my other work here. So -5 from the left, -5 from the right. And it looks like we're approaching a y value of +4. That is going to be my limit. The biggest thing here is that you notice that there's a hole, and we talked about that in try 1. There's a hole on the graph at x equals -5 at my y value of 4. When we are talking about limits, we are talking about the y value that my graph is approaching. We do not actually care about what is for real 100% happening at that value, right? My function is not defined at -5, +4. There's a hole there. But we don't care about that. We care about what my graph is approaching. All right, and that's where the big difference between limits and function notation comes in, because the limit as x approaches -5 of f of x is +4. But if I ask you for the function value, f of -5, well, you're going to look for where it's defined, and that's going to be at a y value of -3. Those are different things. Let's continue, and then we'll be done. The limit as x approaches 4 from both sides. So from the left, from the right, looks like they are the same value. Those are also +4. Excellent. And we can move on. In the second row, letter D, we have the limit as x approaches 2 from the right. Letter E, the limit as x approaches 2 from the left. And then we'll be able to conclude, hey, does the limit as x approaches 2, the general two-sided limit, does that exist? Erase this. 2 from the right. Looks like we are approaching a y value of +8. From the left, we are approaching a y value of +1. I want you to tell me, based on what my one-sided limits are, does the two-sided limit as x approaches 2 of f of x exist? And if so, what is it? According to the limit existence theorem, because my left-sided limit does not equal my right-sided limit, that means my two-sided limit does not exist. And when we are saying does not exist, we can say just DNE, stands for does not exist. And so that two-sided limit does not exist. Anytime we are trying to evaluate a two-sided general limit, we need to check the limit from the left, we need to check the limit from the right, and we need to make sure that they are equal to each other, or else the two-sided limit does not exist. You'll see this meme here on the right. I don't know about you if you have seen Mean Girls or not, but a big, famous, wonderful quote from the movie is when Katie Heron realizes that, hey, the limit does not exist. Well, you guys are AP Calculus students now, and you understand what that means. You have officially found your first limit that does not exist. Wow, life is so wonderful. All right. I think I'm going to have you try a few more on your own, but before I send you off to do that, I want to point out that when you're looking at literally every single limit that we have talked about, and every single limit that you see in these boxes has some function, something that is in the argument coming after the limit. I do not just write the limit as x approaches 2 from the right. Every single time I have an f of x, we could have a g of x, we could have an actual function like x squared plus 2. No matter what, something has to come after, because that's what you're evaluating the limit of that function specifically. If you don't include that, like I didn't have this f of x here, that's what we would consider a naked limit. And if you have any naked limits on your AP exam, the AP graders, like they're not even gonna look at it. If you have a naked limit, they're gonna say, I don't care if you evaluated it correctly, it's gonna count for nothing for me because it's a naked limit. You need to have what you are evaluating the limit of. And so I would go back in your notes, make sure that every limit you have written has an argument, an f of x, or a function. All right, go ahead and try these next 6 on your own, and we'll come back and check them in a minute. All right, we can go ahead and check our work. While you're doing that, something I just want to emphasize one last time, this is a major key point, is that when we are talking about evaluating limits, we care about what the graph is approaching, not actually what's happening at that x value. For limits, what it is approaching, not what is actually happening. On the other hand, when we are talking about like where a function is defined, j, k, and l, that is where we do care about what is actually happening at these x values. Like at f of 2, if I'm going to my graph and I'm looking, well, like up here, I have a hole. That means my graph is not defined or undefined at that value. My graph at x equals 2 is defined at a y value of 1. That's what I care about the most. Like, I don't care about where it's undefined. F of 2 is positive 1. If I'm looking at f of negative 3, I notice that I have an asymptote at x equals negative 3. Well, my graph is never going to be defined at x equals negative 3. That's the whole point and purpose of a vertical asymptote. We know that our graph will never cross it. It'll never be defined there. And so when we are talking about, well, is it defined or is it not? What's the value? Well, it is undefined when we're talking about function value. Super, super important. All right. Folks, you have officially finished your first day of AP Calculus. And this is so, so exciting. I can't tell you. After I took AP Calculus as a senior in high school, just honestly a few years ago, was not that long ago. And I finished the year, I got a 5 on my AP Calc exam, and I found out that when I was going to college, I did not need to take any math anymore. I was disappointed. I was devastated. I was so sad that I didn't get to take any more math that was as cool and fun as calculus. And so I honestly, I am truly honored to be able to begin this journey with you and to teach you this first unit of calculus. And I feel like we should be excited about this, about being able to do this new math that is fresh. We haven't done anything like this before. And so when I tell you that we're going to end our lesson today by doing some Khan Academy practice on the 2 practices that I have here, we should be looking forward to that, looking forward to practicing and learning and growing and getting better so that we can show up tomorrow and learn something new and build off what we did today. And so that's what we're going to do. I have assigned these 2 practices, estimating limit values from graphs, similar to what we've been doing, as well as practicing specifically with one-sided limits from graphs in Khan Academy. That is what I need us to be doing to finish our pre-work. Thanks so much.